Here we are discussing about inter-process communication method. For example, message queues. Message queue is a linked list of messaging stored within the kernel and identified by the message queue identifier. Message queue structure defines current status of the queue. We will discuss remaining things in the next slide. Message queue. Message queue provides a reasonably easy and efficient way of passing data between two unrelated processes. Process 1, process 2 are the two processes. In between that number of messages are there. They are passed between process 1 process 2, but they are placed within the message queue in order. Whenever need to go for transfer the content, they can transfer the messages from any of the different processes. A message queue is a linked list of messages stored within the kernel and identified by the message queue identifier. A new queue is created or existing queue opened by message get function. New messages are added to end of the queue by message send function. Every message has a positive long integer type field, a non-negative length, and the actual data bytes correspond to the length, all which are specified to message send. When the message is added to the queue, messages are fetched from a queue by message receive. We do not have to fetch the messages in the first in first out order. Instead, we can fetch the messages based on their type and the field of corresponding message. Create and access a message queue. First function normally called is message get function to either open or existing queue or create a new queue. For that we are using the method msgget message get function with the key variable int message figure. Key is the name of a particular message queue. MSG-FLG is IPC private only used by the process itself. IPC create new message queue if exist. Ignore this flag. Permission flags to go for using. There are owner permission, group permission and other permission. Return queue identifier on success, otherwise -1 on failure or error. Here, send a message to a message queue. Each message is composed of positive long integer type field, a non-negative length of n bytes, and actual data byte correspond to the length. Messages are always placed at the end of the queue. Here, message ID (MSID) is a message queue identifier. MSCPTR is there, pointer to the message to be sent. Message SZ, size of the message pointed to by the message PTR. This size must not including the long int message type. Message flag controls what happens if either the current message queue is full or the system-wide limit on the queued message has been reached. For that we are using IPC NOW wait return -1 without sending the message. if IPC NOWT will be correspond to and awaiting for the space of to become available in the queue. The returns 0 success -1, the error that shows an error. There is a no message in the data if n bytes is 0. If longest message we need 512 bytes. We can define the following structure. Structure my message, long my type, nothing but positive message type, character m text, that size is 512 bytes. The ptr argument is then pointed to the my message structure. Finally, we said that message queue is a linked list of messages stored within the kernel and identified by message queue identifier. A new queue is created or existing queue is opened by message get function. A new message is added to the end of the queue by message end. Messages are fetched from the queue by message receive. These are all some of the functions that we are using in message queue. Messages are retrieved from the queue by message RCV. Here S size, the specific size of the message RCV, we are consider the function that may returns any integer type or any of the return value consider. Int message ID void message ptr, then size t is equal to n bytes message size, then long int message and int message size. This function return size is data pointed to the message if it is okay, otherwise -1 an error. Here MSC ID is message queue identifier, MSG PTR pointed to the message to be received, MSC SI size of the message pointed to by the message pointer, MSC type a simple form of reception priority, 0 retrieves first available message, greater than 0 retrieves first with the same type of message, it is less than 0 retrieve the same type or less than it message. Here message FIG contains what happens when the message of the corresponding bytes is waiting to be received. IPC not wait, return -1 without sending the message. If no IPC, no wait till no suspended and waiting of appropriate byte of assigned arrived in queue. Return the number of type placed in the received buffer -1 or on an error. Any one of the operation is performed. Okay, message queues. This structure defines the current status of the queue. The members shown are ones identified by single Unix specifications. Each queue has the following message ID, do structure associated with IT. We can define the structure MS QID DS. Structure IPC term message form, nothing but C section next. Message G number T, message Q number or the message on Q. Message length T, message G byte, maximum bytes of length Q. Next PID T, nothing but PID of last message, PID of last message and last message received. Last message with the time. I set magnifies receive with the time. Then int change to the corresponding time. This is the information about message queue using. Okay, let me discuss MSC get function. Int MSG get the function that contains key and int flag. Key is what type of key you want to go for send the information. The flag is depend on the type of work must be considered. Based on that the specific function is performed. Return the message queue ID if it is okay, otherwise -1 if any errors are generated. Here we discuss about message control in message queue. That should be done through the help of the function or API msgctl that returns integer type that contain three parameters. One is integer with the message ID number, message queue ID identifier number. Second one is integer CMD type. Third one is we can call the structure of message ID DS information in the buffers. In that we discuss about CMD. In that CMD, that's a command IPC RMID. That command you can type that removes the message queue MSQID and destroy the corresponding MSQID-DS. Second one, IPC set is the one more command. Set the members of the MSQID-DS data structures from the buffers. You can collect all the data structures from the buffer and then you want to make the setup. Then IPC ST80 is there one more. Copy the members of message ID data structures into the buffers. Whatever the things you want to go for identified and done it in that one, that possible to go for store it in buffer memory. One is from the buffer you want to take, for that you want to go for using IPC set. You want to store it into the buffer, for that you are using IPC ST80. You want to go for making any type of removing of any message information in the queue, that should be done through the help of IPC RMID CMD. Right, this is the value should be command parameters from a message control function, and this function returns 0 if it is okay, otherwise returns -1 if that generates any errors. This is the meaning of a message control we are using in message queue concept. Here we are discussing how to retrieve the messages from message queue. For that we are using message RCV, the API or the function to perform retrieve the messages from message queue. Here this contains different types of parameter. Once again the message ID, MSCQID, then message pointer, right? One more is size, set size with the message size, and long integer with the message type, and also message int with the message length is there. And then we are discuss one by one. Message QID, the message queue identifier. Message pointer point to the message to be received. Then MSQSG is the size of message pointed by the message pointer. Then we are move towards some multiple information about MSG type is there. A simple form of reception priority. If it is 0, then retrieve first available message. If it is greater than 0, retrieve first with the same type message. It is less than 0, retrieve the same type or less than its message. This is what go for using message type the information. Next is message flag is there, MSDFLG. That controls what happens when no message of the appropriate type is waiting to be received. For that we are using IPC no wait control signal that returns -1 without sending any message. If IPC no wait, it will be suspended and waiting for appropriate type of the message arrived in the queue. If it is, finally returns number of bytes in the receive buffer, otherwise it shows -1, that shows an error. This is some simple information about a message, how to retrieve the messages from message queue using the function message RCV with different parameters. Program for message queue. Show to use the message queue information, creator ID and permission of mode number, and then perform the operation between two processes. And if it is called structure to go for get it, what type of structures you can have, and you can get the message ID should be done through the help of calling message get function and perform the operation. And then here it calls one more function, message send function, that possible to go for communicate with the two different processors to perform to communicate each other to send the message and receive the message that should be performed. Otherwise, it shows an message out or it shows the message print is there, sent is there. That information should be displayed with the corresponding function, corresponding program is executed and show the result to the users or the program or the output of the corresponding program.